Now we're going to see how problem 2.9 works if you just go about and use a calculator and some of the values and things that you know. So what you're asking for is to add the components of three forces. So probably your best way is to realize that if each component can be added together, and the best way to go about doing that is using a list. So you need to be able to kind of start figuring out that you're going to be using and making your own list. So we're going to go to list 1 here. There's list 1, and it's got something in it. So we can go here and go second list and look at list 1, right? Or we can do stat and edit list 1. In this case, list 1 has something in it. So very often we can just hit an enter here and we get list 1. If we go back here, we can actually hit clear, and list 1 is cleared. And we can go up and go over to list 2 and clear it. There's all kinds of different ways to go about doing that. List 3, list 4. We've got list 1, list 2, and list 3 right now. And so you can go about putting in your forces in one list, 10, and 12, and 18. And you write down on a side sheet of paper, forces are in list 1. In list 2, we're going to put our angle from the standard position angle, and that's what you'll need to know then, that in fact, that if you're going to know with these forces, the 10 has a direction of 60, and this is a flat problem, so you don't need to think about an elevation angle. The 12 has a direction of 180, and the 18 has a direction of a negative 45. Put those in there, and then in effect, you can go up to list 3 and make list 3 your sum of the forces in the x. So by doing this, by saying, well, it should be the sine, it should be second list, list 1, times the sine of second list, list 2. Close that up and hope it works. And it does. And you have an addition here. You can take out and use your calculator and sum them. And you have something like minus something, some point, something, something. All right, now the problem is that perhaps you can't see list 4. So you might just do this if you can't see it. Second, quit. You might just say second list, list 1 times the cosine of second list, list 2, and I'm going to stick this back into list 3 because we really should put the x's first. We're going to store that into second list, list 3. List 3 now includes, hopefully, something that's correct, though we see we should have cleared list 3, it would appear. And we can do now second list, list 1, star, or times, we don't need to do that, but times second, go to here. You want to say then the sine of second list, list 2, and then you store it into second list, list 4. What's the potential downfall for this? What's your mode set to? So based on that, you can go ahead and see how quickly you can add forces, and then actually have, if you go back to stat here now and edit, a potential to look at what your lists are. If you think about here, second list 1, 2, and 3. List 3 is the forces in the x direction, and list 4, if we would have an ability to go see it, would be the list in the y direction. So how can you do that? You can go back to stat, set up editor, and tell it you want to go second list 1, second list 4, nope, can't see this, second list 1, comma, second list 2, comma, second list 3, comma, second list 4. So when you hit that, enter. Now when you go to stat, and edit, you can see both the forces in the x and the forces in the y. A great function finally then is the sum of all of those. So we're going to hit second quit. We can do second list, operations, math, the sum of second list 3. That gets you your values in the x direction, and you can do second list math. Sorry, I'm going to go back here. Second list sum of second list 4, and you get the values, which should line up with what was done before. That's a much faster way to add concurrent forces and be relatively consistent, especially if you can sketch it out first. Remember, what that requires is drafting your vectors away from the start point. So the 12 had a direction of 180, the 10 had a direction of 60, and the 18 had a direction of minus 45. It then also makes you to control the list. So it is not something that you're just taking out of a program, though there are programs, and writing one for that's a great idea. That is how you go about just adding forces, concurrent forces. And I will point out that as we get going within this, right now we're just looking at the resultant. But as we go through the rest of the course, what you're generally doing is you're trying to find the reaction. And the reaction at any one point is usually the opposite of the resultant. So you cut the structure, you add up all the forces and moments acting on the structure, and then the internal shear, axial force, and bending, or even torsion, is going to be the opposite of what's applied. And that's why we're going through this concept of using both 2D and 3D, getting really maybe overindulged into vectors, but so that when we go ahead and pull off towards Inventor or Revit or whatever else, we've actually thought it out that we can do it by hand and by a calculator. So right here you've got your lists all stored there. If you had some sort of general problem, you'd have a problem, you'd have no big deal to do it. So the next step when you're doing this is to just write a little tiny program that does the same. So in these 3 minutes I'll do that. I'll take a program, got to turn it on. I'm just going to take a program, I'm going to make a new one. I'm going to call it, for this case, second A. Oh, can't do it again. Second quit. I hit a little pause here so I can finish out my 8 minutes to write that program. Okay, here we go. Program, new. It's already taking, so I'm going to give it a better name than that. What is the program going to say? Well, it says this. Second list, which we didn't even do, list 1 times the cosine of second list 2, stow into second list 3. That's the first line. The second line, second list 1 times the sine of second list 2, close parentheses, stow into second list 4. Now what do you want to do? Well, I think you just have to, you probably put this in a variable, but you'd like to probably say second list math. You don't want to do that, so you go back a little bit here. Second list math, sum of second list 3, stow, maybe some other number, alpha x, so it's not a good idea to use x, and then second list math, sum of second list 4, stow into alpha y. In the end, you might want to print those out, but you just, I think, can just say at this point alpha x, enter, alpha, y, alpha, y, and then you generally want to stop your program, and I'm just going to avoid stopping the program to get out of time. I'm going to say second quit. I'm just going to now go to program. I think it was this one here, enter it, and it went ahead and did that. So thanks for listening. That's how to do 2.9 with a calculator, including the program.